All right, so now we get to the tricky part. It's very easy for us to understand definition-wise and even algebraically what these average costs are, but now we're going to be graphing these average costs. So the first one that we start with is our average total cost. Our average total cost is typically U-shaped. Our average total cost is typically U-shaped, so it does something like this. Then we have an average variable cost. Now, the reason why I went through that long situation over here to talk about the average fixed cost and the average variable cost and how they're all related to each other is because the way that you graph this average variable cost it relates to this, right? It relates to this. So we're going to put the average fixed cost really quick, but we're not going to keep it, okay? So the average fixed cost starts at some high value, and then it decreases, 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 and it gets closer and closer to zero. So our average fixed cost starts out at some distance, and then it gets smaller and smaller and smaller. And the reason why I'm pointing this out, and the reason why this identity is important, and I guess there's another identity that we should probably do, right? If we isolate the average variable cost, that's going to be equal to my average total cost minus my average fixed cost. So this means that my average variable cost is going to follow my average total cost curve for the most part, but it's going to be lower than the average total cost curve by whatever the height of my average fixed cost curve is. So the whole reason why I'm doing this is to say this average fixed cost is the distance between the average total cost curve and the average variable cost curve, right? So if we look here, the average fixed cost here is 4 squares. So that means that my average variable cost should be 1, 2, 3, 4 squares below. And then it's going to get closer and closer and closer and closer to my average total cost. And the distance between this, right, it's 4 because the distance between this is 4. And then over here, the distance is, 1.5 because the distance here is 1.5. Do we all understand that? It's a nuanced but important point for understanding these graphs and understanding how to draw these graphs accurately. Let's get rid of all this mucky muck. Okay. All right. So our average variable cost curve lies below the average total cost curve the whole time, and it's typically U-shaped and upward sloping. Typically U-shaped and upward sloping, and it is the distance, the height of the average fixed cost curve is the distance between the average total and average variable cost curve. Our last cost curve is this yellow one, our marginal cost curve. Our marginal cost curve looks like a Nike swoosh sign. And our marginal cost curve is going to cross the average fixed cost somewhere. The important part is it's going to cross the average variable and average total cost curve at their lowest points. So let's redraw this real quick. Almost. Close enough. Then we use the law of large dots in order to show that it's the smallest value on those curves. So in order for our marginal cost curve to be accurate, it has to go through the lowest point of our average variable cost and our average total cost. And actually, this is driving me crazy. It needs to be something like this, I think. Marginal cost curve, generally upward sloping. There's a part at the beginning where it's downward sloping. That's why we get the Nike swoosh sign. But honestly, the part at the beginning where it's downward sloping is always below the average variable cost, so it's never actually a relevant range of production. So nothing to really worry about too much. All right, so when we are, okay, so those are our cost curves. Questions on our cost curves?